Hello everyone, this is your online assignment tutor. Another question. This is a question on application of differential calculus. So it was brought to me. So I want us to solve this question together. Let's look at the question. It said, find the equation of the tangent and normal to the curve x squared plus y squared equals to 5 at point 1, 3. First of all, you must have knowledge on the calculus. If you don't know your calculus, there's no way you can solve this. And you must understand the basic concept in equation of tangent and equation of normal. What is a tangent? A tangent is a line that touches the curve at a certain point. It's a line. While a normal is the line perpendicular to the tangent. What are we saying? So if you have, for example, now, if you have a curve like this, let's say this is a curve. Let's say this is a curve. So a tangent is a line that meet the curve at this point, at a certain point. Don't mind my drawing. It's just for. So this is a line. This line is known as what? Tangent. Why the line which is perpendicular to the tangent, this is what we call normal. Normal. So let's solve this question right away. Solution. So let's look at it. First of all, we are given the equation of the curve. The first you are going to do, you are going to differentiate this x squared plus y squared equals to 5. In mathematics, this is actually an implicit function. So, because it involved both x squared plus y squared, mixing it together. So we are going to, the way I will teach you, the way it was simple for you to be able to solve it. So let's look at the x squared plus y squared equals to 5. So the way I usually do it is this. When you differentiate s squared, is what? That is, bring out the 2x, then 2 minus 1, that is 1. So 2s to the power 1 is equal to as well 2s. Plus, now this is y. When you differentiate y, you are going to put the y ds. Anytime you differentiate y, you put the y ds. So 2y dy ds equals to, differentiate 5, it give you what? 0. Do you see it now? So we are going to make dy ds the subject of the formula. So we are going to have 2y dy ds equals to 2s will go to that side to become what? 0 minus 2x, which is also 2y dy dx equals to minus 2s, because 0 minus 2 give you minus 2s. Therefore, dy ds will now be equals to minus 2s over 2y. You can see cut. So this is the differentiation of the curve. Now, another word for differentiation is known as, is what? Gradient. Another word for differentiation is what? Slope. So gradient, slope. So they tell us that it was a point at the equation of the tangent. The equation of this tangent and normal to the curve is at this point 1, 3. So the gradient now, which is m, which is also dy ds, is now at this point. This coordinate is what? S is equal to 1, y is what? 3. So you put it. S is what? 1, y is what? 3. So this is minus 1 over 3 is the gradient. This is the gradient of the tangent at that point. This is the gradient of the tangent at that point. So looking for the equation of the tangent now, equation of the tangent. Now we'll give, this is the formula, y minus y1 equals to m bracket x minus s1. This m is the slope or the gradient or the differentiation of the curve. And what is s1? S1 is the point that you were given, this 1,3. So let's solve it. So since we have our y1, y minus y1 is 3. Our m is minus 1 over 3 bracket x minus, what is x1? That is 1. So quickly we can cross multiply. So 3 times y minus 3 equals to minus 1 bracket s minus 1. So open the bracket, we have 3y minus 9, 3y, that is 3 times y, 3y, 3 times 3, that is 9, equals to minus 1 times a, that is minus s, minus 1 times minus 1, that is plus 1. So we collect the point together. So we have 3y plus x is equals to 1 plus 9, that is 10. This is the equation of the tangent at that point. So let's find the equation of the normal. The equation of the normal, let's go to the other side of the paper to solve it. Equation of the normal. Now the equation of the normal is given by this formula. Y minus y1 equals to minus 1 over m1. Because, why are you using minus 1 over m1? Because it is what? It is perpendicular. The condition of perpendicularity is what? M multiplied by m1 equals to minus 1. Do you see it now? So m1 is the new gradient of the, so let's just say 1 minus m. So m1 is now equals to minus 1 over m. So this minus 1 over m is the gradient of the normal. So our equation will now become, equation of the tangent will now become y minus y1 equals to minus 1 over m bracket s minus s1. So m1 is now equal to minus 1. Let's find the, what is the gradient before? That is minus 1 over 3. So minus 1 over 3. So of course, you know, minus cancel minus, then you have 1 times, since it's divided, when you introduce time, the 3 will come up, 1 will come down, 3 over 1. So m1 is equal to what? 3. That is m1 equal to 3. So we replace it and say y minus y1 equals to m1 bracket x minus s1. So this is the new equation of the normal. So y minus y1, which is what? Our 3, y minus 3. Because what is our m1? Which is 3 bracket s minus 1. Our s1 is what? Is 1. So we solve. So we have y minus 3 equals to 3x plus 3. So we collect lights together. We have y minus 3x is equals to 3 plus 3, that is 6. 3 plus 3, that is 6. Okay, there's a mistake here. 3 times 1 is what? Is minus 3, sorry. So minus 3 plus 3, that is 0. So y minus 3s equals to 0. You can say y equals to 3s. So this is the equation. This is the equation of normal, of the normal to the curve. So this is the equation of the normal. So we have find the equation. We have find the equation of the normal. We have find the equation of the tangent. Bye. So we meet again. Bye.